So this is exercise 8B.2. We saw in 8B.1 that we got these formulas for sine, cos and tan when what we're cosing is 2 theta. Cos 2 theta, for instance. So we saw definitely last time that sine 2 theta can be written as 2 sine theta cos theta. We saw this formula, which is one of the three versions we saw, cos squared theta minus sine squared theta for cos 2 theta. And interestingly, we didn't see this. This is just an old rule, really, saying that tan 2 theta can be thought of as sine 2 theta over cos 2 theta, which is true, but not necessarily useful for what we're going to do today. These are the formulae we saw last time, and that's what I meant about the three versions. You should recall there are three formulas for cos 2 theta, and all of them can be important. And then the last one, which we saw last time, which wasn't on the initial slide, is that tan 2 theta is 2 tan theta over 1 minus tan squared. And they're not in the formula book. You are expected to know these off by heart, or at least be able to find them and work them out for yourself. It's probably easier if you learn them off by heart. So anyway, bearing that in mind, I've got some problems for us. It says, number one, given that x is acute, okay, sine x is 2/3. So immediately, the fact that it's acute tells me that sine, cos and tan are all positive. We know that from the cast diagram. And I tend to do this automatically whether I need it or not, but I'm going to do it anyway. This is x down here. It says sine x is 2/3. SOHCAHTOA tells me that's opposite over hypotenuse. So that tells me that opposite over hypotenuse 2/3. And this time, in the past, I've always had a Pythagorean triple. This time it's not Pythagorean. So, well, it's Pythagorean, but not a triple. It's not a nice number. So I have to square that one. That's 3 squared minus the 2 squared, and that will give me this. Well, 3 squared is 9, minus 4 is 5. So this is root 5. Don't forget to square root it. So this tells me that cos of x is adjacent over hypotenuse, root 5 over 3. And I don't think I need it, but I'll write it anyway. Tan of x is 2 over root 5. So now I know those. Now what do I need? I want to find cos squared x. An exact number for cos squared x. Now, interestingly, I can get cos squared, I suppose, by using the fact that I know these things are equivalent. Or actually, I'm just about to do that. I don't think I need to do that. I can just do this. That was easy, actually. Easier than I expected it to be. Cos squared x is simply, because I've got cos x, it's going to be root 5 over 3 squared. So that becomes 5 ninths. Let's see if that's the right answer. Oh, I got 1 ninth there. Well, straight away, I've just checked it on my calculator. That should say 5 ninths. I've done it a different way to prove it. So, yeah, so 5 ninths is right. Given that x is reflex and tan x is 8/15, so I wonder if there's a quick way of just doing this as well. I suppose that this time I want sine 2x. I am going to use this formula. So tan x is 8/15. So we'll ignore the reflex for a moment. Tan x is 8/15. So using SOHCAHTOA, 8/15. And that's my x this time. Well, I need this here. Actually, this is a Pythagorean triple, 8, 15, 17. You can again work it out using Pythagoras, using pluses this time. So anyway, I want to know sine x, because I'm going to eventually use this formula here. So sine 2x needs sine and cos. So I need sine and cos. Sine is 8/17. Well, might be. I've got to be careful with pluses and minus. Cos is 15/17. Now just use your cast diagram here. Cast diagram. Now it says it's reflex, which is more than 180 degrees, so it's in one of these two, and it tells me that tan x is 8/15. Right, in actual fact it's here then, because tan is positive. It's in this quadrant here. Now, sine and cos are both positive there and there, and neither is positive here, so these must both be negatives. So let's bear that in mind. Sine 2x then. I don't think it actually matters. 2 sine x cos x. And the sine x we just said is minus 8/17. And the cos x is minus 15/17. So if we just do it on a calculator, what have I got? And I get 240 over 289. So let's see if that's right. 240 over 289. So far so good. We've got a third example, but this is the last one, so then you're back to working from the book in class. So it says use double angle formula, so it's forcing us to find the exact formula of tan 75. Well, for a start, double angle formula is this formula here, so it wants me to do that. Now, normally you half these numbers, so that's not very nice, is it? If I half those numbers, I get 37.5. So I'm wondering, how am I going to do tan of 150 equals 2 tan 75 over 1 minus tan squared of 75. The reason why I say this, because I can probably work out what tan of 150 is. 150 is 30 degrees off 180, so I can think of that like 30 there. So tan of 150 effectively is the same as tan of 30. Well, nearly. I just got to worry about the cast diagram. And the cast diagram tells me that only the sign's positive over here. So it must be minus tan 30. And I know minus tan 30 is minus root 3 over 3. So I know that is minus root 3 over 3. And effectively then I've got, I think, the ability to solve this almost like a quadratic equation. I think it's going to end up like that anyway, so I'll find out. Now, so I'm after working out what tan 75 is. I don't know what it is. I could almost be better off saying x equals tan 75. Then I get minus root 3 over 3 equals 2x over 1 minus x squared. That looks much nicer. Move the 1 minus x squared over. I get minus root 3 times by this thing. So plus root 3x squared. When I multiply that by that. Move the 3 that way, I get equals 6x. So if I move it all onto one side, I get root 3x squared minus 6x minus root 3 equals 0. And obviously I want to chuck this into my quadratic equation solver. And that will give me the answers. So chucking it in menu, go down to that A. It's a polynomial of degree 2. And my first thing is root 3, unusual coefficient, minus 6, negative 6, and negative root 3. Okay, that's given me solutions. Well, actually, it's given me an exact formula. Which I wasn't expecting. I was expecting I almost have to use some kind of other method, but x equals, it says 2 plus root 3, and presumably the next one's 2 minus root 3. Oh, no, minus 2. Minus 2 root 3, plus root 3. So they are the solutions. Now, if I hadn't, say my calculator gave me decimals, I suppose I could always have completed the square, and that would have worked. Not necessarily very nicely, but I could have done it. So I'm not going to bother now. It's given me nice answers. Hopefully the answers. Well, interesting. It says find. It says there's only one answer. Now, is that right? Could I discount one of them? Because the value of tan 75 must be positive. Ah, tan 75 is in here. So cast diagram tells me it must be positive. So presumably this one is not positive. Minus 2. And I know it's not. I'm just going to check it now. Menu 1. So if I do negative 2 plus root 3, it gives me minus 0.26. So that is less than 0, therefore not a value for tan 75. So it gives me an impossible answer. So therefore there is actually only one answer. I wouldn't have thought of that, but I'm pleased I've spotted it. So there's my 3 examples. We are going to go back to exercise 8B. There's the formula again, and in class we'll try our best to hack through these. Best luck.